Hello students, in the last two videos we discussed about the equations of kinematics, and also when the body is a freely falling body with an acceleration for freely falling body with an acceleration equal to the acceleration due to gravity. In that case, how to solve the numericals, and also by using these equations of kinematics, or you can say equations in motion, by using those equations, how to find the position, the distance, displacement, velocity, all these things. And now in this video we will discuss some of the examples or some of the uses that how to represent the motion of the particle in graphical. In graphical means it is the graphical representation of the motion. Here we will discuss about in graphically how we will represent the motion of the particle. That part we will discuss here. So it is very easy compared to using the calculus method or using this by solving the numericals. Already we have solved the numericals by using the calculus method, all these things in the last videos. We have discussed all these things. But in this case, we will solve some of the numericals based on this graphical method. The graphical method. So you can say graphs in motion in one dimension, that we will discuss. So first I will make the concept clear that for graphical representation we require two coordinates. Clear? We require two coordinates, and it means two coordinates means we need two axes. I am not going for 3 dimension. I am taking two axes. One is x axis, the other one is a y axis. Rest. Next, one variable being taken along x axis, the other one will be on the y axis, right? And one thing you remember generally, that the independent variable is along the x axis and the dependent variable is along y axis. Usually you consider the independent variable is along x axis and the dependent variable is along y axis. Clear? Now, involving the time as one of the variable and it is an independent variable, so I will consider the time along the x axis and the other parameter what we will discuss, the parameters like distance, or you can say position, or you can say displacement, or velocity, or acceleration along y axis. So time is fixed along x axis, it is independent. According to time you can change your position, you can change your velocity, you can change your acceleration, so that is along y axis. In that way we will make the graphical representation or study the graphical representation of motion in 3 cases. One is the position time graph, next velocity time graph, next acceleration time graph. So first we will discuss about the position time, or you can say distance time graph. First I will discuss about the position time graph. We will discuss different cases in position time graph, or you can say this is also the distance time graph also. We can say distance time graph, or you can say it is a one dimension motion and the particle is moving in a straight line. Displacement time graph also you can say the magnitude of the displacement. Here you cannot show the direction part, magnitude of displacement time graph. Clear? Okay. Are you getting? Yes. Okay. Now first I will case when the particle is stationary. First case, when the particle is stationary. Particle is stationary. What it means? A particle is at rest Means when there is an observer, you are an observer at the point O, and you observe that there is a particle at P which is at a distance of x naught, which is a distance of x naught from O. It is at a distance of x naught. So I can show this x naught like this. So it is at a distance of x naught from O, and O is the origin. Means you are the reference point, you are standing at O, and you observe that the particle is at the point x naught and the particle is at rest. So when the time passes, you are finding the particle is at that position at P. So how to represent that graphically? The simple logic is that, so I will consider the time axis T along x-axis independent, and the position suppose as x. I will consider this as a x. So at time t is equal to 0, when you observe from here, where is the particle? At P. So it is, suppose this point is your x naught. This distance is your x naught. So the particle is at time t is equal to 0, x naught. At another instant, the particle is at rest. Then the particle is rest. So if you join all these things, you will get a straight line parallel to the time axis. So this is the position time graph, isn't it? So this is the position time graph for a particle at rest or particle is stationary. Clear? Is that clear? Now, so from here, the particle, when the time passes, the particle is at the point P. In the same case, suppose the particle at time t is equal to 0, suppose this particle at time t is equal to 0 is at the origin. So it is not moving. So at the origin, the particle is at the point. Means O and P coincide at the same point. Then in that case, what I will do? This line is parallel to time axis because this position is 0, or you can say distance s also, s is 0, it has not covered any distance. So if you make this distance time graph, then it is also along the time axis because it is a 0. Clear? Now we will go for the second one. So the particle is moving with constant velocity. When the particle is moving with constant velocity, second one, particle is moving with constant velocity. Particle is moving with constant velocity. Constant velocity. Okay. So the particle is moving with a constant velocity, okay, from O to P. So let you are at the point O, the particle is moving towards right. Right? The particle is moving towards right with a constant velocity or a constant speed in this direction. Clear? So at you are the origin O and the particle is moving towards the point P. Okay. Now in this part moving along this direction, so it will be not at P, it is moving along this direction. So if it is moving with a velocity v in time t, so at a time t, what the distance it will cover from P? That is Vt. And already suppose this distance is already covered x naught. The particle starts from here, suppose the particle starts from here at the point P and it is covered like this. So the particle, you are standing here, the particle starts from the point P which is already covered a distance x naught from you and it is moving with a velocity v along this direction. So what is the distance traveled at time t1, t2 like that? So velocity v with a constant velocity, so v is constant. At time t1, what is the distance? vt1. At time t2, vt2. At a time t3, vt3. Like that, you will use this one. So how to plot this graph? Now you see here. So this is the time and you are taking the position or the distance x. So in that case, at time t is equal to 0, where is the particle? At P. At what distance? X naught. It is at x naught. From there, it moves with a constant velocity. It is moving with a constant velocity, right? So from there, it is moving with a constant velocity. So if it is moving with a constant velocity, then it is a line like this, Vt, right? So this is the Vt. Means it shows that when the moving towards the right, the particle is moving towards the right, we can show that its distance from the origin goes on increasing. Its distance from the origin goes on increasing as the time passes. as the time passes. Is that clear? So here's the position time graph of the moving particle with constant velocity towards the right. It is moving towards the right. Will be a straight line inclined to the time axis. Inclined to the time axis. Okay? And if I will ask you what is the angle made by the line towards the time axis, you can find the angle like this. So I will take a parallel line to this time axis. So this is the angle theta. It made with the time axis. So in this case, if I will take tan theta, that is called as the slope of the line, tan theta. So slope of the line means tan theta, means if I plot it like this. So what is this one? This one is delta t. Suppose I consider this distance is delta t. And what is this one? Delta x, obviously. This is parallel to x axis. So this is obviously delta x. So tan theta is equal to slope, that I can write as delta x by delta t. What is this one? This is the velocity. If it is displacement by time, velocity, or if it is distance by time, it will be speed. So the slope of this line is your velocity. The slope of the position time line or position time graph will give you what? The slope of the position time graph, or you can say distance time graph or displacement time graph. It will give you the magnitude of the velocity, or you can say speed, right? So this is the most important thing. Clear? Now in the same case, the particle is moving toward the right. Suppose the particle starts from the origin. Now the particle starts from the origin O and moving with a constant velocity v towards right. Right? It is moving towards the right with a constant velocity. Then I will ask you draw the position time graph. Then you will show t and x. Clear? It will be a straight line passing through the origin. It will be a straight line passing through the origin. Then, because it has not covered this distance, at a time t is equal to 0, where is the particle? Here at O. But here the particle starts from P and it is moving towards the right. So it is shown like this. And what is the slope of this line means? Suppose I will ask you, what is the velocity of the particle in the interval like this, t1 to t2? In this time interval, what is the velocity? Then what we will do? Draw the slope. Draw a line parallel to time axis. All have to know about the slope. How to draw the slope. Draw a line parallel to the time axis. Okay, this is the line. What is the slope? This is the slope, theta. And what is this tan theta? Tan theta is equal to, you can show this one. This one means what? Suppose this is your x2, this is your x1. So what you will write? x2 minus x1. This is the distance divided by tan theta equal to this height by base t2 minus t1. So this will give you the average velocity in this interval. It is the average velocity, and the particle is moving with uniform velocity. So average is equal to instantaneous velocity. So the slope of the line of the position time graph gives us velocity. Make it like on your, or memorize this thing. Clear? Now suppose in that same case, if I'll ask you, if the particle is moving towards the left, then what we will show? How to show? Means the particle is moving towards the left. So this is one case. Particle is moving towards the left. It means what? Let the particle starts from here. O is the origin, you are standing P. It is already at a distance x0, and from P the particle is moving in this direction with velocity v. In this direction towards left. Means its position decreasing, isn't it? Position decreasing. So if I show you how to draw this one, t versus x. It starts from x0 at time t is equal to 0. Yes, it is at x0. Clear? Then this position decreases, this distance decreases like that. So it decreases like this. Now what is the slope of this line? Slope means how much the line inclined with the x-axis, your time axis. Your x-axis means your time axis. How much it is inclined. Along which direction? Along positive x direction. Along positive, not negative. Right? So if you say this side, it is also inclination, but we will consider this one. So here you see theta. Theta is greater than 90. Theta is greater than 90. So means the line will be like this, decreasing, the portion goes on decreasing like that. So at a particular time, the particle comes like this with a speed and it will reach to the origin. Then after that it will go along this direction. So along this direction means towards the negative x-axis. So if this is 0, this is positive x-axis, this is negative x-axis. So that's why I have taken this as a negative x-axis. Means this is the negative x-axis. And what about this theta greater than 90? Slope is negative. The slope will be negative, isn't it? Slope is a negative. Slope means tan theta. If theta greater than 90, tan 90 is a infinity. So if the value greater than 90, it will be negative. Theta greater than 90, it will be negative. The slope is a negative. Clear? Now, next we will go for the particle is moving with constant acceleration. The particle is moving with constant acceleration. Third case, particle is constant acceleration. When the particle is moving with constant acceleration, particle is moving with constant acceleration. What is? When the particle is moving with a constant acceleration. Understand this thing. Since let the particle is moving towards the right, and the velocity is increasing in the right direction. Clear? So means here I consider the acceleration is positive. So in that case, what is the position time graph? Remember this thing. What is the position time graph in this case? When we plot the position time graph or the distance time graph, let the case is like that. The particle is moving like this. At time t1, at this point, its velocity is v1. At time t2, its velocity is v2. And the particle is moving along this direction, towards the right. And velocity is increasing because this is a positive acceleration. I have considered that a positive acceleration. So if you plot the position time graph. So as you know, when the particle is moving with like that, then we will use the equation x is equal to distance equal to, or s is equal to ut plus half at square. So the position is increasing. With two factors like with t and t square. So the nature of the graph changes. Like that. So how it changes? In what way it will change? X. So in this case, it will be a curved line that is a parabolic. Means it looks like a parabolic equation. So it will looks like a parabolic equation like that. At time t is equal to 0, position x, then increasing for this velocity for v1 to v2. If you use that one, it is a parabolic equation like that. It is increasing. Clear? Now, here from there, this position time, so the particle is moving with a constant acceleration. That is, velocity is increasing, means positive. Acceleration is here, I have considered positive acceleration. So the line will be parabolic. It is a parabolic. Because velocity is changing like that. Acceleration is equal to dv by dt. And a is equal to d by dt. Velocity is equal to ds by dt. So s is your x. So it is double derivative. Acceleration equal to d square x by dt square. Already we have discussed this thing. So for this type of graph, acceleration with position, double derivative. So this is the parabolic line for positive acceleration. Position increasing, velocity is increasing. Positive acceleration, velocity is increasing. I am moving at 2 meters per second. Now my velocity is 5 meters per second. Next 7 meters per second. Next 13 meters per second. Like that, the velocity is increasing in one particular direction towards right. So this is that curve. Then in that part, remember, if we plot from this position time graph, if I will take the slope, that will give me, if it is a position time graph for constant acceleration, if the slope of the line will give us the what? the slope of the line will give me as a velocity. Very good. So in that case, suppose I will find the velocity at this point and the velocity at this point, two positions. Now check this one. For at a time t1, what is the velocity? At time t2, what is the velocity? I will take the slope. So to find the slope, what I will do? In that case, remember, when we are finding at an instant, at this instant particular, I am not finding an interval. So at this point means draw a line like this. Let me show like this. That is the tangent to the line. Very close. This is the tangent. This is the tangent to the line, to the curve, to the parabolic line. This is the tangent. Clear? Obviously, this is the graph and this is the tangent. Then the slope means, suppose this is the angle theta 1. Then here you will find, now see here. Here the tangent will be like this, the straight line. Joining this line, this is the tangent. So if this is a line, draw a tangent here. What you will do? Like this. This is the tangent. Very close to that line. Take 2 points. How to draw the tangent to a line? If I make, let me clear this one. Okay. This is a curve. Suppose I will ask you what is the tangent at this point. Take a very close point near to this one. How much it is possible? Then draw a straight line like this. So this is the tangent. Like that I have drawn the tangent. Clear? I have drawn the tangent. So it is not possible to show you, like this is a straight line. So don't get confused. This is a straight line. So what is the slope of this line at this point? Now plot parallel to this time axis like this. So this will be theta 2. Now by observing these two, yes, you tell me, by observing this slope at t1 and slope at t2, tell me, here in this figure, which one is greater? It looks like which one is greater? Obviously theta 2 is greater than theta 1. Then if theta 2 is greater than theta 1, then tan theta 2 is also greater than tan theta 1. So the slope at t2 is greater than slope at t1. Slope at t2 is greater than slope at t1. Are you getting that? Right. So the slope gives me the velocity. Means I can say, suppose at this time t2, the velocity is v2, which is greater than v1. The slope of this line will give us the velocity. So here the velocity is increasing. Clear? That's the idea we are getting from this particle moving with constant acceleration towards right, or the velocity is increasing. Clear? So in that case, if particle is moving with a constant acceleration and the acceleration is negative, means the velocity is decreasing. Velocity is decreasing. Clear? So in that case, we will say that for this one, so the particle is moving like this, velocity v1, velocity v2 at time t2, at time t1, and the particle is moving towards like this, and the velocity is decreasing. Velocity is decreasing. So here the acceleration will be negative. So how the nature of the graph? The nature of the graph. Okay? Means we can say the particle is moving towards the left. You think that you are at this point. Right? You are on this point. Here the origin is. And you are finding the particle is moving left. Right? So in that case, if you plot the time versus distance or position, then here in this case, it is the nature. It is the nature of the graph. Means if retarded motion, it is the retarded motion. So the position time graph or distance time graph for a speeding down, retarding motion, and is decreasing with the time. The distance is decreasing with the time because the particle is moving towards the origin. Origin is somewhere here. You are standing here. The particle is going towards you. So naturally the distance is decreasing. So you can show like this. In that case, again, if I'll ask you, this is obviously this is a parabola, but here, now if you find the slope at two different positions, at this point and this point, suppose I will take the slope at this point. What is the slope at this point? At this point, slope. So suppose this is T1 and suppose this is T2. Now you see here, slope is, take a tangent at this point, then draw a line parallel to time axis. Suppose this is your theta1, then theta2. This line, max. How much inclined with the time axis? That will be the slope, theta2. Means what? Here, which one is greater? Theta1 is greater than theta2. So tan theta1 is greater than tan theta2. Obviously, because tan 0, 0, tan 90, infinity. If the tan theta value increases, tan value increases. So slope of this one is greater than this one. Means that when the particle is speeding down, velocity decreasing, slope is decreasing, particle velocity is decreasing. So if the graph is shown like that, then you can understand what that. Yes, the particle is moving with a constant acceleration, and this is not positive, this is a negative acceleration, and this is a retarding motion. That we can understand by knowing this graph. Clear? So this is the nature of the graph. Okay. So velocity goes on decreasing. Okay. Now after knowing all these things, again another thing you remember, for this velocity for a particle moving with different cases, like your first we will discuss about the position time graph for a particle at rest, then we will discuss about the particles moving with a constant velocity towards right or increasing distance, decreasing distance, then a particle is moving with a constant acceleration. Okay, constant velocity and constant acceleration, how the position time graph, all these things we have discussed. And remember one thing, this position time graph will never like that. You will never find the position time graph, position and time graph like this. Time, at a constant time, the position is increasing. It is not possible. Means the particle you are finding at time t is equal to 5 seconds. The particle position is 10 meter, then 13 meter, then 15 meter, then 70 meter. It will never find. So this type of graph is not possible. You will never find this position time graph like this. Similarly, the position time graph you will never find. You will never show this type of position time graph or distance time graph. Means the distance is decreasing like this. You will never find like this. This type of graph you will never find. If it is drawn anywhere, you say that yes, this is a wrong one. Means the time passes, the distance decreases. No, the particle will go like that. The position is not decreasing like that. So not possible. The distance covered cannot be decreased with time. Decrease with increase in time. Therefore, this is not possible. Okay. Similarly, if it is shown like that, time with position, you will never get a graph like this. You will never get like this, because it gives two positions for the particle at the same time. At the same time t, there are two positions. This is x1, this is x2. There are two positions for the same time. This is also not possible. So if this type of graph are shown, then you can, so this is not possible. So this is about the position time, distance time, or you can say the magnitude of the displacement time graph. Okay students, now we will go for the velocity time graph. Okay. So in this velocity time graph, first we will show that particle is moving with a constant velocity. How we will show this one? Particle, first case, particle is moving with constant velocity. Particle is moving with a constant velocity. How we will show this? The velocity is constant as the time passes. So if you show the velocity time graph, means obviously this side is velocity and this is the time. As the time passes, the particle is moving with a constant velocity. Suppose the velocity at time t is equal to 0, it is a velocity v naught or u, then this u remains same. So the velocity constant throughout the time. So this is the velocity time graph for a particle, right, moving with a constant velocity. Or you can say here, what is the acceleration? For a particle moving with constant velocity, what is the acceleration? 0, no change in velocity. Acceleration equal to change in velocity by time. There is no change in velocity. So in a time interval at t1 to t2, suppose I will consider from t1 to t2, what is the change in velocity? 0. This v remains same. So the acceleration is also 0, right? And here the most important thing what we can find, if I consider in this case, suppose I take within the time interval t1 to t2. So I will make this as a, b, c, d. Okay. So in that part, what is this area a, b, c, d? If I ask what is the area a, b, c, d, means it is a rectangle. So you can say that CD multiplied by AD. What is the CD? CD is nothing but T2 minus T1. Yes. What is this AD? Suppose that is your V naught with a velocity V naught constant. So V naught. So I can say V naught. What is it? This is a delta T. So velocity into time. And obviously this is the magnitude part. Means this is the area of this portion. Velocity to time means, as you know, the velocity or the speed, we can say here, magnitude of velocity, speed is equal to delta, suppose this is the x by delta t. So delta x is equal to v naught into delta t. What is this delta x means? Distance covered, if it is speed, or magnitude of displacement. If we will consider this as a displacement, magnitude. So this is the velocity, magnitude, speed. So magnitude of displacement means the area below the velocity time graph, represent as what? Distance traveled by the particle. Is that clear? So the area between the velocity time graph and the time axis gives the displacement of the particle here. So if this is the case like this, suppose I will take another example like, so let us take another example. When the velocity time graph, in that case, particle is moving with a constant positive acceleration. Now I will ask you, what is the velocity time graph? So as the time passes, velocity goes on increasing because particle is with a positive acceleration. Hence, the velocity time graph for a particle moving with a constant positive acceleration will be a straight line inclined to time axis. Means suppose at time t is equal to 0, velocity time graph. So along y-axis we will take consider velocity, along x-axis time. So at time t is equal to 0, suppose it has a velocity, it starts from u. Then it goes on increasing. So velocity goes on increasing. Clear? So if this means moving with a constant positive acceleration. So for a constant positive acceleration means for each interval the velocity is increasing in a equal values in equal intervals of time. Then it is a constant acceleration. Constant acceleration means what? Equal amount, change in equal amount of velocity in equal intervals of time. That is a constant acceleration. So here in this case we can say the velocity and also the acceleration both are in the same direction, isn't it? Velocity and acceleration are in the same direction because it is a positive acceleration. The motion and acceleration are in the same direction, then it is a positive acceleration. Think about this, okay? So we will get, if you think about this, okay, my motion and means my velocity and acceleration are in the same direction, means someone is pushing me, accelerating me. So it is like that. Then in that case what you will find here, the slope of the velocity time graph. The slope of the velocity time graph, in this case, what is the slope of this velocity time graph? Obviously, if I will ask you, what is the slope of the velocity time graph? Draw a line like this parallel to this one. So this is suppose theta, slope means what? Tan theta. So now draw a perpendicular here, tan theta is equal to this, delta V. Suppose this is delta V. What is this one? Delta T by delta T. What is this one? Acceleration. And theta is acute. Theta is less than 90. So A is positive acceleration. Clear? Suppose in the same case I will ask you, particle is moving with a constant negative acceleration. Means what happened? Velocity is decreasing. Yes, velocity is decreasing. Means at time t is equal to, it is a velocity u, then it goes on decreasing like this, decreasing to make the slope. What is the slope? Inclination to the positive x-axis. This is the slope here, theta. Means velocity is decreasing, means velocity along this direction. Motion and acceleration are opposite. The motion of the particle and acceleration are opposite, then the velocity is decreasing. Then tan theta again, if you find the slope, tan theta, okay? So what is this tan theta? Tan theta is equal to delta v by delta t. So the slope here, theta is greater than 90. Theta is greater than 90. So theta is greater than 90 means what? Here the negative acceleration, hence is a theta is obtuse, hence becomes a tan theta or tan theta becomes negative, then acceleration is also negative. Yes, clear. Now suppose I will go for a the velocity time graph when the particle is moving, or then the motion of the particle is with non-uniform acceleration. When the particle is in non-uniform acceleration, what is the velocity time graph? Particle, it is about constant. Particle is moving with non-uniform acceleration. Non-uniform acceleration. What is the velocity time graph? Yes, velocity and time for non-uniform acceleration. Suppose the particle goes on increasing like this, then it will be like this. Here, equal proportionally it increases, then it is a curve one. So it is a non-uniform acceleration. Particle in equal intervals of time, the velocity is not changing in equal interval, or the velocity is changing in equal intervals with non-equal intervals of time, or non-equal intervals of time. Okay, and the slope of this Vt graph at any point gives the instantaneous acceleration. Suppose I will ask you, what is the instantaneous acceleration at this point in this type of curve? So it is curve one, then you go for the slope instantaneous, means at a particular instant. So to make this at a particular instant, I will make a tangent like this. Slope means draw a parallel to this one. This is the slope theta. Here is this theta. So here you can say the acceleration is velocity is increasing. Velocity is increasing. Obviously the velocity is increasing, right? Because theta is acute, tan theta is positive, so velocity is increasing. Always like that. Tan theta slope. Check theta is less than 90 or greater than 90. Theta is greater than 90. Then the slope is acceleration. Velocity time graph. The slope of the velocity time graph, acceleration. The slope of position time graph or distance time graph, velocity. The area below the velocity time graph, distance. Like that. Next, this theta. Suppose the particle is moving with a non-uniform, right? With decreasing, the velocity is non-uniform velocity, but the velocity is of which the acceleration of which is decreasing with time. Acceleration is decreasing, right? If I will ask you, show the velocity time graph for a particle, the acceleration of which is increasing with time and decreasing with time. So the same case is, in the same case, here in this portion, theta is like this. So if I will show you graph like this, let me make it clear. Suppose I have a graph like this and the particle is showing like this. Okay. So in this case, particle is moving with a acceleration. Here the particle is moving with an acceleration of which decreasing with time, right? Means decreasing with time. Then let us compare. The acceleration is decreasing or not? Let me say, what is the slope at this point? It is already a straight line. this is theta. So here suppose theta 1, theta 2. Now we compare these two. Which one is decreasing? The slope of this one. So this is a straight line already. So no need to, if it is a chord, then you will draw a tangent. So here you say theta 1 is greater than theta 2. So the slope, when the particle time passes, the velocity is decreasing. Here the velocity is increasing. Velocity is increasing, right? So that is the conclusion. Okay, I think I was told that it is a increasing velocity. No, it is a velocity is decreasing. Here the velocity is increasing. Okay. Now from here, okay. So the slope of this one will give you the velocity time graph. Then I have a question like that. So for the particle, I got an expression like that. The velocity time graph is shown like that. You can show a time versus velocity. And the particle has like this. Suppose 1, 2, 3. 3 portions I have got. The particle has a velocity like this. Velocity time graph I plotted and I got this thing. So in this case, if I ask you what is the displacement of the particle and distance covered by the particle, remember what is the distance? Distance and displacement. From this graph, what is the distance covered? Distance means area below the velocity time graph. So one area is this one, first one, second, third. That is the velocity time graph. So this is a velocity time graph. Third. So the distance time graph is equal to area 1 plus area 2 plus area 3. Suppose I will ask you what is the displacement. Remember, displacement, when you are considering the displacement, then above this area 1, yes, plus 3 positive, area 3 minus area 2. That is the importance of this equation. Area 2 negative minus, yes, because when we are considering displacement, we have to consider the direction. We have to consider the direction part. Distance, no need to take that is direction. But here it is negative velocity. Velocity is positive in this side, negative in this side. Clear? So this is the velocity positive side and this is the velocity negative side. Negative velocity means negative displacement. Area is minus here. So that is the importance of this equation. Similarly, the velocity time graph, you will never find perpendicular to the time axis. You will never find a velocity time graph where the line is perpendicular to the time axis, right? Because it requires infinite acceleration. Then you will never find the velocity time graph for a closed curve like this. You will never find a velocity time graph like this. Velocity time graph like a closed curve. You will never find like this. Okay. Similarly, you will never find a velocity time graph like this, because at the same time there will not be two velocity. At the same time, the particle should not have a two velocity. You will never get this type of equations. Okay, this type of graphs. Okay, so these are the different ways of representing the velocity time graph. Okay, understand this thing. Then we will go for the acceleration time. Now the acceleration time graph for a particle moving with constant acceleration. Particle is moving with a constant acceleration. First one, for acceleration time graph for a particle moving with a constant acceleration. Okay, so when the particle is moving with a constant acceleration, so what we will take here, obviously time is along x-axis, acceleration, because it is acceleration time graph, we will plot like this. Constant acceleration means with respect to time the acceleration remain constant. Clear? So this is the acceleration time graph. Okay, if the particle is moving, suppose acceleration is not a constant, acceleration is not variable acceleration, means acceleration is not constant. Here the acceleration is constant. In next case we will go for the acceleration is not a constant acceleration. So variable acceleration. Number 2, particle is moving with a variable acceleration. Particle is moving with variable acceleration. Time and acceleration. Sorry, it is not velocity, acceleration time graph, acceleration, variable. So the time passes, the acceleration is changing in a random manner. So we can show like that, if the particle is changing like this, the acceleration is changing like this. Okay, now this is the variable acceleration. Now the most important thing is that suppose in this acceleration time graph, I am getting an acceleration time graph. For the result of this one, the acceleration time graph, I got an acceleration time graph like this, and suppose the graph is like this. I have got a graph like this, acceleration time graph. What the significance of this graph, or what the data we can get from this graph? It is only one nature of graph. It is the variable acceleration. Acceleration is not changing at a, acceleration is not constant, the acceleration is variable. It changes with respect to time. Okay. Suppose I will ask you, what is the velocity from this graph? Velocity of the particle in this graph. In this case, what we will do, what is the velocity of the particle in this interval of time, dt, very small interval of time, dt. Suppose I will ask you. Then, so it is almost a straight line thing that this dt is very, very small. So this is, suppose the acceleration is 0 per a naught. Let us consider this acceleration is a naught with a time interval dt. So as you know, a is equal to dv by dt, change in velocity by time, instantaneous acceleration. So dv is equal to a dt. So a means here a naught, suppose a naught in this case. So a naught means this line. So this is like a rectangle, very small rectangle. So this line is almost equal to this line, think that. So this is a naught and this is dt, right? So for a rectangle, product of the two sides, right? Length into breadth, that is the area of VT graph, sorry, AT graph. Area of AT graph will give you what? The velocity, change in velocity. Okay, so we can get that the change in velocity is equal to area of AT graph, or area under AT graph, not of, area under the acceleration time graph. Okay, in this case again it is a vector quantities, right? Obviously this is the vector dv, acceleration dv. Suppose I got a graph like this, so means the area below the acceleration time graph and above the time axis, that area will represent you the velocity. Suppose you have got a graph like this, time and acceleration. I got a graph like this. Let us take more time. 1, 2, 3. Okay. Now, what is the, from here, what is the velocity in this time interval from 0 to, suppose any time t, what is the graph represent? The change in velocity from 0 to t, if I will ask you, what is the change in velocity from 0 to t? Here, area, change in velocity, delta v, change in velocity is equal to area below this velocity, acceleration time graph, so this area, and it is positive, obviously above, positive, so area of 1. How you can find this area, that is different thing. You can make this triangle, so the area, that is a problem part, we will discuss. In nowhere I have discussed how the area will be calculated. You will do the area below the acceleration time graph will give us the velocity, so change in velocity. So change in velocity in this portion means this area. Now this velocity area, it is negative area, negative axis, so minus area of 2, that my point to discuss. Then this is a plus area of 3, because this is a velocity, is a vector quantity. That is the importance of this acceleration time graph. Got it? Now we will go in a freely falling body, if I'll ask you for a freely falling body, how to draw the graphs for a freely falling body moving under gravity, for a particle moving under gravity, for a particle moving under gravity means acceleration is equal to g. Acceleration is equal to g. So if for a particle, if a body dropped from some height, dropped from a height, where at this position, suppose this is the body, is dropped, this is the ground, it is the height h, suppose, and the particle is dropped from here, u is equal to 0, and the particle is dropped, u is equal to 0, and the particle is dropped here, right? So suppose this is the origin, here the particle is dropped and this is the origin. If I ask you what is the position time graph, xt graph, I will make one by one, xt graph. How will be the xt graph? Yes, x t. Where we got this type of, in this position time graph, the nature of position time graph like this means moving with a constant acceleration. Particle is moving with a constant acceleration. The position time graph will be like this. So position distance increases with time. Okay. So this is the position time graph or s distance time graph. Right. Next, velocity time graph. Velocity time graph. For the same case, velocity time. If I ask you what is the velocity time graph, from here 0, position is 0. Suppose this is the origin, from origin it starts, no velocity, velocity is 0. As the time passes, velocity increases. The velocity is increasing. Okay, and the slope of this one will give you, suppose I will ask you what is the distance traveled in this interval, area below the velocity time graph will give you the distance traveled. What is the slope? Slope theta. Slope of this one will give you this tan theta is equal to the this distance dv by dt, delta v by delta t, acceleration. Slope of this one will be give you the acceleration. Here the acceleration is what? G. Acceleration is equal to g. The slope of this one will give you g. Area below the velocity time graph give you area below vt graph, above area below vt graph, this area distance. That is the conclusion from here. Similarly, the acceleration due to gravity, here acceleration is equal to g for free falling case. At graph remain constant, acceleration versus time constant. What is this value? G. A is equal to g. Clear? So if a body is vertically dropped from a height, okay, and if the body is projected vertically upward, projected vertically upward, projected vertically upward, how we will show this one? Position time graph, velocity time graph, acceleration time graph. Body is projected upward. So this is the ground, this is the height, suppose to a height, or I don't need to take this height here. Here the ground, the body is projected here, u is equal to 0, and this is the origin. You are standing here, u is equal to 0, dropped from here, and the body is moving with an acceleration equal to g. Right? In that part, what you will find here? Find the position time graph. Means what? So A will say that direction of motion is going up, positive. Direction of motion will be positive. So means if it goes up, it will go to a certain height. Then the case is like this. It will go like this, then come back. This is the motion. You will consider this whole system. goes up, then comes down. Here the final velocity becomes 0, then it will goes down. If I will ask you the position time graph, what is the position time graph? Increases, then comes like this. Same thing, it increases, then comes down. Okay, what is the highest point? What is the maximum height attained? Yes, maximum height, this value will be u square by 2g. The body will be u square by 2g. Okay, so here not u is equal to 0. In this case, u is equal to 0 means the body will be there. It is given with the initial velocity u, final velocity is 0. Okay, make the correction. Okay, you with the initial velocity, you have throw that with the initial velocity. If u is equal to 0, how can you throw the body? Clear? So this is the case. So maximum will be, maximum height is u square by 2g. Then the distance decreases. Velocity time graph. Yes, velocity time graph. Yes, u increases. You have given them u, now goes up. U goes on decreasing and becomes 0. Goes on decreasing. Here it is u with a velocity u, velocity time graph, and comes to 0. Then negative 0. Then it will drop down. It will fall. You will consider this fall. If the body thrown up, it will not goes up. It will come back. So we will consider the back portion also. Projected vertical upward means if it is goes vertical upward, then it will come down. So it is like that. Okay, and this is the time of flight. What is the value? Time of flight goes up. Time of ascent, time of descent. So this is time of ascent. What is the time of ascent formula? This value must be u by g. Then if you consider this time, if the body is like this time is 2u by g. Time of ascent, time of descent, total is the time of flight. So this is the time of flight, 2u by g. Think about this. Okay, I am drawing this very fast. Then acceleration time graph. Acceleration time graph. Let me draw this one. Acceleration time graph. Acceleration time. When the goes up, g pulling down, acceleration decreasing. Motion in this direction, acceleration this direction. Always acceleration in this direction. The acceleration due to gravity. Motion and acceleration opposite direction. So negative. This is minus g. Negative axis. Okay. So these are the different types of position time graphs. So analyze these graphs. Think more and more. Then you can get a clear idea about this graphical representation of motion. Okay. Thank you.